In this lecture, we are going to discuss the solutions for the Polytechnic Physics 2021 Supplementary Examination problems. So we are discussing the solutions for some problems which were asked in the supplementary problems. We first consider part B type questions. First question is the derivative of the analytic function e power x into cos y plus I sin y is. So there are four options are given. Here f of z is equal to e power x into cos y plus I sin y. Cos y plus I sin y is equal to e power iy. So this is e power iy. Therefore, this is equal to e power x plus iy, which is equal to e power z. So f of z is equal to e power z. So the derivative f prime of z is equal to, once if it find the derivative of f of z with respect to z, this is again e power z. So the solution is the option A is the correct one. F prime of z is equal to e power z is the correct option. So option A is the correct one. Then the next question, the poles of this function is integral over c f z plus 4 divided by z square plus 2z plus 5 dz is. So the poles are asked. So you consider the function f of z plus 4 divided by z square plus 2z plus 5. So the poles can be obtained by making the denominator is equal to 0. Z square plus 2z plus 5 is equal to 0, and solving for z. So z is equal to, so by using the standard for minus b plus I minus square root of b square minus 4ac by 2a. So this is the standard form of the solution for the quadratic equation. So you use this one, z is equal to minus 2 plus or minus 4i by 2, which is equal to minus 1 plus or minus 2i. So the option C, minus 1 plus or minus 2i, which is the correct answer. The next question, if we have tensor AIK, this is a covariant tensor AIK plus BIK of second rank. The sum of the two tensors AIK plus BIK is equal to CIK. Then the rank of the tensor is now here AIK plus BIK. This is a subscript which is equal to CIK. Here this is a tensor of rank 2, covariant rank 2. A tensor of similar type can be added, as well as alone can be subtracted. So if this is a covariant tensor of rank 2, that alone can be added. So after the addition, the final product also gives the same type and rank. So CIK is also the covariant rank of rank 2, covariant rank 2. So the solution is B. The option B is the correct answer. The next question, the velocity of a fluid at a point is a covariant vector of rank 1, contravariant vector of rank 1, and so on. Velocity is always a contravariant vector. So velocity is always a contravariant vector. Contravariant tensor of rank 1 or contravariant vector. So the option is B. The correct contravariant vector of rank 1 is the correct option. Then we will go to the next question. An electrical circuit consists of a capacitance C and an inductance L. If I is a current flowing to the circuit and Q is the charge across the capacitor of a particular instant, then the Lagrangian of the circuit. So the options are given, 4 options. So you consider this circuit. This is a L inductance and capacitor circuit. Current I is flowing through the circuit. Now here we assume this is a key. Now the energy stored in the conductor is of Li square. So when current is switched off, then there won't be any energy stored across the inductance. So whenever current is flowing, then there is energy. So this energy is your kinetic energy of Li square. But the energy stored across the capacitor is equal to of Q square by C. So even if you switch off the circuit, the energy is accumulated across the condenser. So this energy stored across the condenser is your potential energy. So the Lagrangian of the system is L is equal to T minus V. T is the kinetic energy and V is the potential energy. Kinetic energy is half L I square. Potential energy is half Q square by C. So T minus V. So this is your expression for the Lagrangian. The option C, which is given here. So option C is the correct one. The next question. An old set of coordinates Q suffix k, P suffix k are transformed into a new set of coordinates black letter QK and PK. So this is a capital letter through a canonical transformation. If the generating function for the transformation, is of type 1. So type 1 means the function is F1, type 1 function, which is a function of small q, capital Q and T. So we have already derived an expression relating the old coordinate and the new coordinate with the function F1. P suffix k is equal to partial d F1 by dqk. Pk here, this pk and this is qk. This is a canonically conjugate variable. Capital Pk and this is a capital Qk. They are related conjugate variable. So this is related by minus partial df1 by dqk. So here the option is D. Option D. This is a partial df1 by dqk is equal to pk and partial df1 by dqk is equal to minus pk. So option D is the correct one. The next question, the transformation equation for a canonical transformation are given. Capital Q is given by logarithm of 1 plus square root of Q cos P, and capital P is equal to root Q into 1 plus square root of Q cos P sin P. If the generating function for the transformation is of type 3, type 3 is F3. F3 is a function of small letter p and capital letter Q. Now here first you have to show that p dq minus capital P dq. So it must be an exact differential. So if it is a canonical transformation, and this must be an exact differential. So we can easily show that this is a d of q into p minus half sine 2p. So this is an exact differential. Now we have this relation partial df3 by dp is equal to minus q, partial df3 by dq, capital Q is equal to minus p. So also from q is given, capital Q is given. So from this we can easily get a small letter q is equal to e power q minus 1 whole square secant square p. So partial df3 by dp is equal to minus q. We have already calculated q, so we substitute value of q here. Now integrating, you will get this expression f3 is equal to minus of e power q minus 1 whole square tan p. So the result is the option C is the correct result. Then a relativistic Hamiltonian of the particle of rest m0 moving at the velocity v under the potential v of r is given by. Here there are 4 options are given, and the Hamiltonian h is equal to summation over d by dx dot of m0 c square into 1 minus the square root of 1 minus v square by c square minus v into x dot minus m0 c square into 1 minus square root of 1 minus v square by c square into vxi. So this is available in some standard books. So you have to remember this expression to calculate this problem. To solve this problem, so this you take this is a expression. Now here this is h is equal to m naught summation of xi dot square divided by square root of 1 minus v square by c square minus m naught c square into 1 minus square root of 1 minus v square by c square plus v of xi. And now simplifying this one, and summation of xi dot square is equal to xi dot is v. So if you perform the summation, it will be v square. So m naught v square by square root of 1 minus v square by c square minus m naught square c square into 1 minus square root of 1 minus v square by c square plus v of xi. By simplifying this, you will get this expression m naught c square into 1 minus square root of 1 minus v square by c square minus 1 plus v of xi. So this is here. The answer is option A. Option A is the correct answer. Actually, this is a lengthier problem. It may not be possible to solve it within 2 or 3 minutes. So it needs at least 10 minutes to solve this problem. So this is option A is the correct one. The next question, find the expectation value of R for the wave function. The wave function for the hydrogen atom problem is given, ground state wave function. So the expectation value is equal to the integral psi star r psi, and this is r square dr sin theta d theta d phi. So you have to, this is the to find the expectation value of any variable, and you have to use this expression. Now psi is given, so substitute for psi, and the psi is independent of theta and phi, so that can be easily evaluated over theta and phi. So integral over sin theta d phi is equal to 4 pi. So so you can write down 4 pi because this is a r integral. So you take only the radial part alone, 0 to infinity e power minus 2r by a r square dr. Now this integral can be evaluated because this is a standard integral. So once you evaluate this integral, you will get this expression, which is 3 by 2a. So option C is the correct answer. Next question, if sigma, the Polish matrices, sigma plus is defined as sigma x plus I sigma y, and sigma minus is equal to sigma x minus I sigma y, where sigma x, sigma y, sigma z are the Polish matrices. Then you are asked to find sigma plus, sigma minus. So they are operators. Sigma plus and sigma minus are operators. So substitute for sigma plus, which is sigma x plus I sigma y. Sigma minus is equal to sigma y, sigma x minus I sigma y, you find the operator multiplication. Sigma x is equal to sigma x square. Sigma y is sigma y square. Here plus minus, so there is a minus, and there is a minus, and the I is also present, so I and I is a minus, so this term is again a plus value. Then you combine the other terms, I into sigma y sigma x minus sigma x sigma y. Now sigma x sigma y is equal to I sigma z. Sigma y sigma is equal to minus I sigma z. Sigma x square, sigma y square are, they are 1. The values are 1. So if substitute this value, so this is 1 plus I into this is I sigma z plus I sigma z. Simplifying this, we will get 2 plus 2 sigma z. If you take 2 as a common factor, 2 into 1 plus sigma z. So option D is the correct option. Then you consider the next question. Here, let psi is equal to 1 by root 2 of ket phi 1 plus square root of 3 by 2 ket phi 2, where phi 1, phi 2 are the eigenfunctions of two distinct values of E1 and E2, then the expectation value of E. So the expectation value of the energy is equal to P1 times E1 plus P2 times E2, where P1 is the probability of the system having the energy E1, because it is having only two states, so the energy is E1. Another state is having energy E2, and the probability is P2. And the probability is defined by the modulus of the coefficient square. So P1 is equal to, here 1 by root 2 is the coefficient of this 1 by root 2 is the coefficient of the ket phi 1. So you find the modulus square. So that is your P1. So 1 by root 2 mod square is 1 by 2. P2 is equal to modulus of square root of 3 by 2 whole square, which is 3 by 2. So if substitute these values, expectation value of E is equal to 1 by 2 E1 plus 3 by 2 E2. So here the correct option is C. Next question. The spherical harmonics YLM function for the L is equal to 1 and M is equal to 0 is. So the general expression for the spherical harmonics YLM function, which is a function of theta phi, is equal to some epsilon square root of, this is the general definition, say epsilon times the square root of 2L plus 1 divided by 4 pi L minus mod m factorial divided by L plus mod m factorial PLM of cos theta e power m phi. This is associated Legendre function. Now this epsilon is equal to minus 1 whole power m for m greater than 0, and the epsilon is equal to 1 for m less than or equal to 0. Now for our problem, because L is equal to 1, m is equal to 0, this is reduced to 3 by 4 pi whole power half cos pi. So the option is C. C is the correct option. So write down the general expression and you substitute for L is equal to 1, m is equal to 0. This function reduces to this form, 3 by 4 pi whole power half cos theta. The next question is, a charge of 1500 microcoulomb is distributed over a very large sheet having surface area 300 meter square. The electric field at a distance of 25 centimeter is. Now here the expression for the electric field is equal to sigma by epsilon 0. Sigma is the charge density, so charge divided by area. So 1500 and this 10 power minus 6, this is a microcoulomb. Area is 300, so this is sigma is 1500 and 10 power minus 6 divided by 300. Epsilon value is equal to the permittivity of free space 8.85 10 power minus 12. once if you substitute this value becomes 56.49 10 power 4. So option D is the correct one. The next question. So here there are 4 charges are located at the corners of the square Q1, Q2, Q3, Q4, and the distance, the sides are having equal distance A. Now you are asked to find the potential at the center. Now the potential at this center is equal to 1 by 4 pi epsilon Q1 divided by R. R is the distance from the charge Q1 to this point. So this is R plus Q2 by R plus Q3 by R plus Q4 by R. You know the values of Q1, Q2, Q3, and you know the R value is also given. R is a constant value that can be taken outside. So 1 by 4 pi epsilon 0 R, and the substitute value of Q1, Q2, Q3, Q4. And if you simplify, the result becomes this is 360 divided by 0.71. You find this is the 507 volts. So this is option A is the correct one. The next question. The physical meaning of entropy can be understood by the following statement. Entropy is a measure of entropy means a degree of disorderness. So the option C is the correct one. The next question. Entropy can be defined as a thermal property of a substance which remains constant during. So D is a change in entropy is defined by dq by T. For adiabatic process, dq is equal to this is q is a constant, so dq is equal to 0. So since dq is equal to 0, ds is equal to 0. ds is equal to 0 means this is a constant. So option A is the correct one. The next question. What is the vibrational frequency corresponding to the thermal energy of kT, which is equal to 298 degree Kelvin. Now h nu is equal to kBT. So nu is equal to kBT by h. The h is a Planck's constant available. Boltzmann constant is also known. So substitute T is equal to 298. So once if you simplify, you will get the answer is 62 into 10 power 11 this is the hertz. So option D is the correct one. The next question. Calculate the minimum kinetic energy at which a neutron in a collision with a molecule of gas is oxygen can lose energy by exciting molecular rotation. So the bond length of the oxygen is given. So bond length is given. So here delta E. So this is equal to 2B Hc, where B is a rotational constant. So once if you multiply by Hc, you will get the energy in joules. Now here mass of oxygen molecule is not given in this problem. So this value is given here, which is 26.56 in 10 power minus 27 kilogram. So you have to find the reduced mass. Reduced mass is m1 m2 divided by m1 plus m2. But here both all masses are equal. Mass of oxygen O16 into mass of O16 divided by 2 times this value. This is half times m of O16. Once if you calculate, this is the reduced mass is 13.28 10 power minus 27. Now, so you know the value. The bond length R is given 1.2 in 10 power minus 10 meter. Once if you substitute this value in the above expression, and you will get the value, the energy in joules. In order to convert the energy in joules to the energy in electron volt, you have to divide by 1.6 in 10 power minus 19. So once if you do this division, you will get the result is obtained in electron volt, which is 3.628 10 power minus 4 electron. So option A is the correct one. The next question, a system of protons at temperature 25 degree centigrade is placed in a magnetic field of 2 Tesla. What is the ratio of number of proton spins in the lower state to the number in the upper states? So let us assume N0 be the ground state and N1 be the upper state. According to the Boltzmann statistics, N0 by N1 is equal to e power delta E by kT. Delta E is given as G suffix n mu n B0. This is G is a lambda G factor. Mu is the magnetic moment. The values are this is not given, Gn is not given, but if you know this value, you just substitute this value mu n, the neutron magnetic moment, which is available 5.051 in 10 power minus 27, and B0 is given, and you find the delta A, and KT, K Boltzmann constant is available, T is given, so you find delta E by KT, which is 13.71 in 10 power minus 6, and once of a substitute, you will get N0 by N1 is equal to e power 0.00014, and if you simplify, if you find the value using a calculator, you will get this is 1.000014. So these values must be available, mu n, Gn, also calculator